Welcome students. Today we are going to learn a new lesson, electric charge and electric current. So let us learn about electric charge, electric field, electric potential and electric force in this video. Electric charges. Inside each atom there is a nucleus. See the picture. Inside each atom there is a nucleus with positively charged protons and chargeless neutrons. So proton have positive charge and neutrons has no charge. So chargeless neutrons and positively charged protons are present inside the nucleus of an atom. And electrons orbiting the nucleus. So it has negative charge. Usually there are as many electrons as there are protons, and the atoms themselves are neutral because number of protons are always equal to number of electrons. If an electron is removed from the atom becomes positively charged. See here in the first picture there are 6 protons and 6 electrons. So here protons and electrons are equal in number, so the atom is neutral. But see this third picture, here this atom is positively charged because inside the nucleus 6 protons are there, but electrons only 5. Here one electron is removed from the atom, so the atom becomes positively charged. Then it is called a positive ion. Here see the second picture. If an electron is added in excess to an atom, then the atom is negatively charged and it is called a negative ion. See here, there are 7 electrons. Here, 1 electron is added to this atom. So, it becomes negatively charged atom. So, like that when you rub a plastic comb on your dry hair, the comb obtains power to attract small pieces of paper. Is it not? When you rub the comb vigorously, electrons from your hair leave and accumulate on the edge of the comb. Your hair is now positively charged because it loses electrons. As it has lost electrons and the comb is negatively charged, as it has gained electrons. See before rubbing, after rubbing. So here the electric charge is measured in coulomb and the symbol for this electric charge is capital C. The charge of an electron is numerically a very tiny value. The charge of an electron is the fundamental unit with a charge equal to 1.6 into 10 to the power of minus 19 coulomb. So this value is the charge of an electron. This indicates that any charge, so electric charge is represented by the letter Q. So any charge Q has to be an integral multiple of this fundamental unit of electron. So Q is equal to NE. Here N is a whole number. So practically we have microcoulomb, nanocoulomb and picocoulomb as units of electric charge. So microcoulomb, nanocoulomb and picocoulomb. So 1 microcoulomb is 10 power minus 6 coulomb, 1 nanocoulomb is 10 power minus 9 and 1 picocoulomb is 10 power minus 12. Micro means 6, nano 9, pico 12. So electric charge is additive in nature. The total electric charge of a system is the algebraic sum of all the charges located in the system. For example, let us say that a system has 2 charges plus 5C and minus 2C. Then What is the total net charge? The total or net charge on this system is plus 5C plus minus 2C. Here algebraic sum of these two charges, plus 5C 5 coulomb and minus 2C 2 coulomb. So we get 3 coulomb plus 3 coulomb. So this is the net charge of the system. So problem, how many electrons will be there in 1 coulomb of charge? So charge of 1 electron, the value is 1.6 into 10 to the power of minus 19 coulomb. So we know that what is the formula? Q is equal to Ne. So here how many electrons? N. So from this formula we derive N is equal to Q by E. So number of electrons in 1 coulomb is 1 by 1.6 into 10 to the power of minus 19. So 6.25 into 10 power 18 electrons. So 1 coulomb charge contain 6.25 into 10 power 18 electrons. Next, electric force. Among electric charges, there are two types of electric force. That is, one is attractive and other is repulsive. The like charges repel and unlike charges attract. See, like charges, both are positive and here both are negative. So like charges repel each other. Then unlike charges, one is positive and one is negative, they attract. So the force existing between the charges is called as electric force. The force between the charges. So these forces can be experienced even when the charges are not in contact. So next one is electric field. Next one is electric field. What is electric field? The region in which a charge experiences electric force forms the electric field around the charge. See the picture. So the region in which a charge experiences the electric force forms the electric field. So this electric field is represented by lines and arrowheads indicating the direction of the electric field. So electric field is represented by the letter E, then it is represented by lines and arrowheads that indicates the direction of electric field. So the direction of electric field is the direction of the force that would act on a small positive charge. So therefore the lines representing the electric field are called electric lines of force. So the electric lines of force are straight or curved paths along which a unit positive charge tends to move in the electric field. So electric lines of force are imaginary lines. The strength of an electric field is represented by how close the field lines are to one another. So for an isolated positive charge, the electric lines of force are radially outwards, and for an isolated negative charge, they are radially inwards. See the direction of arrow. For isolated positive charge, it is outwards. Then for negative charge, it is inwards. So electric field at a point is a measure of force acting on a unit positive charge placed at that point. So a positive charge will experience force in the direction of electric field and a negative charge will experience in the opposite direction of electric field. So see the picture. A positive charge will experience force in the direction of electric field and the negative charge will experience in the opposite direction of electric field. Next one is electric potential. We know that in the region of electric charge there is an electric field. Other charges experience force in this field and vice versa. So there is a work done on the charges to keep them together. This results in a quantity called electric potential. So what is electric potential? It is a measure of the work done on unit positive charge to bring it to that point against all electrical forces. See the picture. It is a measure of the work done on unit positive charge to bring it to that point against all the electrical forces. Students, hope you all understood about electric charge, electric force, field and potential. Thank you.